You know, it's kind of wild to think about how ancient builders made these perfectly symmetrical structures without any of our modern gadgets. Well, today, we're going to unlock one of their classic secrets, how to slice an angle perfectly in half, and all you need is a compass and a straight edge. Seriously, it's a simple trick that feels like a little bit of magic.
Okay, so here's the puzzle. Imagine you've got an angle, right? And your job is to split it into two perfectly equal halves. But here's the catch. You can't use a protractor, no fancy digital tools, and absolutely zero guesswork is allowed. So how in the world do you get that perfect precision? Well, let's dive in and find out. All right, first things first. Let's get one quick but super important word out of the way. Bisect. All it means is to divide something into two perfectly equal parts. And that's exactly our mission today. We're going to bisect an angle. Basically, we're creating two smaller, identical twins from the original. Now for our toolkit. And this is where it gets really cool. We only need two super simple things. A compass, for drawing arcs, and a straight edge, just for drawing straight lines. But notice what's missing. There's no ruler, no markings, no numbers. That's the secret sauce here. We're going to get perfect precision without measuring a single thing.
All right, here we go. This is what we're starting with. Angle ABC. See that corner? That's point B, what we call the vertex. And our whole goal, the entire mission, is to draw just one single line that cuts this angle perfectly in half.
Okay, time to grab that compass, because this is where the action starts. First, just set it to any width you want. Seriously, it doesn't have to be a specific measurement. Now stick the pointy end right on that corner, point B, and just swing a nice smooth arc so that it crosses both sides of the angle. And just like that one little arc has given us two super important new points, right where it hits the lines of the angle. We're going to call them D and E. Think of these 2 points as our guides for everything that comes next. Okay, listen up, because this next part is absolutely crucial. Whatever you do, do not change the width of your compass. Just lock it in place. Got it? Good. Now keeping that exact same width, put the compass point on D and swing another arc, kind of out in the middle of the angle. Awesome. Now we're going to do that exact same thing, but from the other side. So again, without changing the compass width, move the point over to E. Now draw a second arc so it crosses right over the first one you just made. And that spot, that little X where they meet, that is exactly what we've been looking for. And there we have it. That little intersection right there, that's our final critical point. Let's just call it F. All that careful work with the compass was just to find this one exact spot. And now, we're ready for the final, super simple step. So think about it. We've got our original starting point B, and we've got our brand new target, point F. The entire solution, the whole shebang, is now just about connecting those two dots.
Yep, it's really as simple as this. Just grab your straight edge, line it up, and draw one straight line from the original corner B right through our new point F. And that's it. You've literally done it.
And look at that. What we started with, that one single angle ABC, is now perfectly split into two smaller, identical angles, angle ABF and angle FBC. They are exactly the same. No measuring, no guesswork, just pure, beautiful geometric precision.
So, why does this work? Like, every single time, perfectly? Well, it all comes down to symmetry. Remember how we kept insisting not to change the compass width? By doing that, we were secretly building a hidden shape, a rhombus to be exact, and the geometry of that shape forces our point F to be the exact same distance from both sides of the original angle. So it's not magic, it's just really, really clever geometry creating perfect balance with just a few simple arcs.
It's pretty amazing when you think about it, right? This ancient technique takes what seems like a complex problem, getting perfect precision, and boils it down to a few simple, foolproof steps. Which kind of leaves us with one last thought. What other things that seem totally impossible might actually become simple once you find the right blueprint?